Physics 37, and we are. So you should have noticed, I think I did update the syllabus over the weekend. And so it's got all that stuff in it. And got a test coming up. Guess I wanted to do a few problems for you, like recitation, before we
Yeah,
go
sure.
on to
Could you solve
Newton's.
number 20 from the homework? I have a question about integration.
Um, Before we go on to
Or
Newton's
like a similar
laws.
problem. Or like a
And
similar one. I just have a question about integration because I don't understand like when they set it to 0, I don't understand how they're integrating that. I really need to see like somebody do it. Just so so I can understand going forward.
Okay, sure. Can you pull up number 20 and share the screen and show me what problem you're talking about?
Oh, okay, sure. Let me just go right here. And then
I think it's set up that it switches around. It's not the same for each student, each problem. Oh.
So you just want me to share my screen? Okay, cool. Oops, let me just make sure. Oops. Thanks. Make this a little smaller.
Thank you.
No problem. Thank you. Thank you.
So unfortunately, my eyesight is going a little bit. So
you want me to load it up?
If you can do that.
That better?
A little bit better, yeah, thank you. There you go, that's good. The ship is located further north and 250 kilometers east of the ship, of ship B. Ship A has velocity 220 kilometers toward the south, and ship B has a velocity of 37 kilometers per hour in direction 35 degrees north of east. What are the x and y components of velocity of A relative to B? Axis directions are determined by the unit vectors I and j, where I is toward the east. At what time is the separation between the ships least? What is the least separation? So why do you think you need to do integration or do whatever for this? I don't see this. This is not an integral problem.
Integration is at step C. So
what is the time?
Integrate, and I don't understand.
What is the time?
I don't understand.
What is the time separation between the two ships? At what time is the separation between the ships the least? Okay, maybe. Okay, I can see that. So that's a it's a minimization of I don't know if it's integration though. It's like when you minimize a function, you take the derivative and set it equal to 0, right? So you
Right.
might have to set up a function. Okay, let me check. Yeah, I think that's my first inclination. Let's go ahead and set it up and see what we got. All right. And it just occurred to me, did I do that? Oh, there's a section that I usually lecture on, which has to do with relative velocity, and I'm not sure that okay, well, maybe we'll spend the day doing that. Need to go back and put that section in. Let's see if we can try to do this. Ship A is located 44 kilometers north and 2.5 kilometers east of ship B. So what I'm going to do is set up a coordinate system where I put ship B at the origin. So I'm going to do something like this to mention that, or this is north, right? And this is east, and 270 degrees is south, and 180 is is west. So ship B will place here at the origin. And ship A is 4 kilometers north and 2.5 kilometers east. So I don't know, 1, 2, 3, 4. 1, 2, 3, 4. But each of these represents 1 kilometer. Make this a little larger. So 4.5 kilometers north, or 4 kilometers north. So that's going to be and 2.5, 1, 2, and something like here. So that's how I would set it up. B. So 1, 2, 3, 4, making this kilometers. 1, 2, 3, 4, 5. Again, kilometers. Now they have velocity vectors at those points. We can represent the velocity as vectors. So ship A has a velocity of 22 kilometers per hour toward the south. So ship B or ship? Oh no, this is A. So now ship A has a velocity vector. Now, technically, it's a vector that represents. I'm just sketching it, so I'm not really following that. Because you only really need to do that if you're gonna use like a graphical method to figure out the thing. We're not going to use a graphical method. We're going to use an analytical method, but I still like to draw the picture because I'm a visual learner. So I'm not really being careful to make these vectors, velocities represent specifically the velocity, but whatever, just want to put that in. So this is 22.0 and it's kilometers per hour, I guess they're doing. And that's due south. And this guy has velocity vector 37 kilometers in a direction 35 degrees north. North of east. So north, this is east and north of east. So yeah. All right. So that means basically 35 degrees relative to the x-axis. That's what that means. So I'll make this guy a different color. We don't necessarily be drawing the 45 was like that, 30, maybe like this. So that's the velocity vector of this guy. Now I'm going to project this thing on out just so we can kind of visualize the angle. So this is what, 37, I think it said? 37. Actually, let me put this over here. 37 kilometers per hour. That's that guy. And this angle here is 35 degrees. So that guy, I'm just going to call it theta. So put these details over here. Theta is 35.0 degrees. Velocity or speed, I'd say speed for ship B is 37.0 kilometers per hour. ship A is 22. That's the speed. I remember velocity is direction, but we kind of have the direction incorporated in the direction of the arrows of the vectors. 22 kilometers per hour. Per hour. Yeah. So I can kind of see what they're getting at in that part C, just to kind of project ahead a little bit. It is I think a minimization problem. So what's going to happen is these things they don't necessarily they're not going to hit each other, I guess, but they're going to cross, and there's going to be a minimum point where they're closest, right, as you move along. So in the problem solving technique that I set up with you, this is what I would call the demonstration part. So I guess I've kind of done it all at once because we had to kind of see what they're talking about to get before we got to step 4. But now I'm just starting back at step 1, just thinking about the overall situation. So they're moving like this, and I guess this is the original position. So something like, I don't know whether this is going to cross first or this is does like that. I don't know. But at some point, there's going to be a passing and there's going to be a minimum point. So basically, the distance between them, the actual is closing, and at some point it gets a minimum, and then it starts to separate again. You see that, Kimberly, and everybody else? See that?
Yeah, yeah,
So
absolutely.
you remember from calculus, whenever you remember, it's probably like chapter 5 or 6, in calculus 1, where you got to minimizing a function. And how do you minimize a function? You
I
take the
forgot.
derivative. I'll tell you right now, that's good because this is, you forget, I forgot too until I got to a physics class and then had to do it, with something that represented a physical problem. But it's a big thing. It's a thing that physicists use a lot. If you can get the equation for the function, the way you minimize it is you take the derivative of it, then set it equal to 0, and then solve for whatever the variable is, and that value will tell you the value at which that function is a minimum. That's how you do it. So I'll outline that when we get to part C, but that's something that it's a tool that you want to use as a scientist because it doesn't just apply to physics. It applies to, it's not even physics, it's math, right? It's calculus. But when you apply it to a physical situation, this is an example of a problem where that would be applicable to. Any function you have, any kind of function, whether it's chemistry, biology, anything, even population size, like if a pandemic comes in and and is killing people in a population, if you can find how that virus is spreading through a function and equation, and there are equations to define this. There's like, I think I talked about this on the first day, diffusion equations, how a virus or something, if you have the functional form, and usually you don't, because that's a much more complex problem to define functionally than something like this. But if you do have it, you could basically tell how many people, like when the thing is going to be maximum and the most people are dying, and then when it starts to, statistically when it starts to pale off. And so you can get a curve of, and we saw those kinds of curves actually. We saw those kind of, they didn't show them as an analytical curve, but they showed them as like block, because you'd have to have more information to be able to do what we're about to do here. But I'm just saying that the minimization of a function is a big deal in science. And this is the kind of problem that it's applied to, either minimum or maximum. It depends. You do it the same way, but depending on how the function is, whether it gives you a minimum or whether it gives you a maximum. In calculus, they also call it extreme values. So like it's a chapter where they talk about finding the extrema, plural, of a function. It's the same, it's similar to that. So
Right.
that's
I
what
just
this is about.
forgot. Yeah, I
Yeah.
remember that. I just forgot how to I forgot
Yeah.
how to set it up. I don't know. Probably because I was thinking more like bond value because I came from ODE. That was my last math class, ODE. So I got kind of stuck there. So I just kind of,
Ordinary different equations.
I
Yeah.
applied that a lot. I use that at Pickaby a lot. Ordinary
Yeah.
differential equations. So you have to just
Right.
refresh me real quick, and I remember.
Yeah. Well, honestly, in your defense, you probably actually didn't do this because in calculus, they actually give you the equations. Here, we've got to create the equation that we're going to take the derivative of. That's actually not that easy. I mean, it can be easy depending on the problem, but I'm not sure that that's something that you actually did in the calculus class, unless they gave you the word problems to do it, which most people don't. They just show you how to do it, and then there is a section where they give you and all the word problems would be stuff like this. But usually, like when I had calculus, we didn't do it in calculus. We just figured out how to do the thing analytically, and then we moved on. So you probably actually haven't done all of what this is
I
asking
don't
you to
remember.
do.
I'm not gonna even lie to you, because if I'll just tell you the truth. I really don't remember.
It's all good.
Because I've been
It's all
out of
good.
calculus so long. That was my whole point.
Yeah, it's
Like
all
I've been
good.
out of calculus for a minute.
Yeah, it's all good. So let's see if we can do it. So the first part is so what are the x component and y component of the velocity? Okay, so that's fine. So we can just write that down. That's going to be easy, I think. For VA, so VA x is going to be 0, right? Because it's going due south, so there has no components in the x or y direction. And VA y is going to be minus 22.0 kilometers per hour. So that's part of, let's call this part A. And then for B, well, we just got to take the components. It's going to be the for velocity B, VBX is going to be equal to VB times the cosine of 35. Okay, so let's go ahead and write that in. So that's going to be 37 times cosine of 35, which is 37 times 35 cosine times, what is it? 30 point in story one. So 30.3.
30.3 it should be.
30.3 kilometers per hour. We can keep it in that. I'm not going to convert it to meters per second. I don't think we need to. Generally, I would, but I don't think we need to necessarily do that for this problem. And then VBY is going to be VB times the sine of 35. So VBY then is going to be equal to, and go ahead and check my math with me, Kimberly, please. So 37 enter 35 sine times. So 21.22 store 1. And again, I'm not truncating this when I write it on the board. I'm just right because I can't write everything, but I'm storing the stuff. I only round off in the very end. So 22.2 kilometers. Actually 22.3, I think it rounds off. But anyway, no. I'm keeping all that stuff and all these numbers in my calculator. And I'll only round off the final answer. So that's the components. And part B, okay, that's A and B. All right. Axis directions are determined by the unit ij, where x is toward the east. Yeah, good. And what is the time? What time is the separation between? What time is the separation between the ships least? What is the least separation? Okay, so this is a little bit challenging. How do you do this? So we got to kind of figure out how to find the function. Well,
I actually have functions for B. So I know, right, because I understand up into this part, right? I understand, I do understand this part. So I have
okay.
right here,
Well, you tell me, how did you find the function?
2.5 minus 30.31, and then I subtract J. But it's the step C that has me like so challenged. You know what I mean? I don't know if because I didn't want to like take too much of everybody's time, but I do understand this part. The next step, right? We just basically subtract J and add the vectors, which would give us like 2.5 minus 30.31I plus 4 minus 43.22J. Right? That's our next step. But it's after that, when you're minimizing the function, as you say, I don't understand it, because it's like they get this figure. I don't even know where they got it
I
don't
don't know if
understand it.
I haven't looked at
I'm
it,
sorry,
but
but
there's,
I'm gonna let you talk.
okay. So let's establish a protocol. So I don't mind you talking, that's fine, but we can't talk over one another. And I don't want to interrupt one another because ultimately that if you're talking over and interrupting, then it hurts the communication. So you're fine. You're fine. I want you to talk. This is a great problem, actually. But you talk, I listen, I talk, you listen. And that's not just for you, it's for everybody. So um, I got a question. Can you repeat the function that you said you have, or the next step you said you understood? Could
Yeah,
you repeat what you
absolutely.
said
Because
again?
we have minus 22J, and basically we just um take both of the distance and subtract J. So I have vector 2.5 minus 30.31 I plus 4 minus 43.22 J, because remember I had to subtract J from that point. So I mean you can go ahead and do that. I didn't want to take, because I know the problem was, it seemed like I was taking up so much of your time. That was the only reason why kind of like, I didn't mean to cut you off, but I was letting you know I didn't want to take up your time. So
Yeah, yeah,
yeah,
you're
that
good.
was the problem that I don't know if you want me to write it out, but I mean I can write it in the chat box for you, and then the next step. So that way you'll
I'm
understand.
just letting
I
you.
think it's better
I'm
like
just.
that.
I'm just. I'm not sure what just happened just now, but I'm doing the problem. So I mean, it's a good problem to do, and I'm sure if you had a question about this, and everybody else did, and also this is a recitation day. Like that's what I had planned to do in preparation for your exam coming up. I wanted to work through problems. There's not much other theory we have. I've gone through all of it. Although I just realized I do want to say something about relative velocity, which is kind of related to this problem. I had some lecture stuff on there that I think I forgot to say the other day. So you're good. You're good. This is a recitation, kind of class today. So working problems is what I had planned to do, and this is actually a pretty good problem. So you're good. You're good. But what I guess sometimes in physics, like in problems, kind of like in math, sometimes the problems fit very well to the concept. Sometimes they give you problems where this is like kind of a math thing. The concept that, because I told you in my problem solving technique, um, usually I like to identify in step 5 the physical concept that you need to solve the problem. But because mathematics is the language of physics, sometimes it's not a physical concept, it's a mathematical concept. This problem is like that, which is probably why you don't know how to do it. And it's a very good problem. I'm really glad you brought it up, because if you don't know, I'm sure like many people don't know, because it's not something that's in your physics book. It's actually a mathematical concept, and it comes from, that's why I spent that whole time talking about minimization, because these are the kinds of problems that you would have seen in the calculus book in that chapter where they talked about minimizing and maximizing a function. So it's something that we handle in physics in like mathematical methods. And at this level, so there's actually separate classes for that, but at this level for the intermediate, we kind of do it inside the class. So that's what I'm going to try to do for you right now. So what's happening is you got the initial distances here, which are what you said. I forgot to write that down. So basically, I'm going to call it XA, and XA, its coordinates are um, was it two uh, uh, 4 kilometers. Uh, so actually no, so 2.5 kilometers x and 4.0 kilometers y. And the position for this guy, I conveniently placed at 0, 0. Right. So right now, the total distance between them this is the Pythagorean theorem, right? If you look at just it's basically this length right here. This is the way to see this in any problem like this. And again, this is for any sign, any kind of function. This is the distance between them. And from the Pythagorean theorem, that distance, we could work it out, right? Let me just call that distance R. okay? So r is equal to x squared plus y squared to the 1/2 power, okay? Now, what they're asking you to do is to minimize, that's actually the function. You got to minimize that function because as these things move closer to one another, that distance is decreasing up to a point, and then when they pass, that r is going to start to increase. So that's the kind of the bird's eye view. That's the function that they're asking you to minimize. But what we have to do is, I think the mathematical term is parameterize it. Parametric equations type is also involved because this r is not just dependent on these physical positions, it's also depending upon time because these things are moving and the velocity is dependent upon time. So what we have to do is find this function, how this function relates or what its relationship is to time. In other words, we have to figure out r of t. And once we do that, then time becomes the independent variable, and r of course is the dependent variable because that position r is dependent upon, its value is dependent upon at what time we look at it, and also that's indirectly dependent upon the velocities and direction of the things moving. So it's that kind of deal. Once we find the r of t, the function r of t, then we can take the derivative of that function and set it equal to 0, and then we can solve for whatever we need to solve. So that's so the concept here is basically, I don't know what the mathematical term is, minimization or maximization of functions, whatever. And also Pythagorean theorem, because that defines the distance between them. At any point you can define that in whatever. Let me see if I can remember how to do this. And the thing is, it's kind of like when we do get to integration, whatever relationship helps you define the thing that's valid. So I think what I'm seeing here, what's jumping out at me is this x distance. So we can look at the individual distances. This thing is x, is y, and this deal is x. So as this thing decreases, that distance is decreasing. The delta x, between them is decreasing, and the delta y is decreasing. But what we know is because that's related to velocity and time by definition. In other words, if I think of it as a delta x, then let me number these equations. I'm going to start numbering here. This is just basically information, all this stuff. Like in the problem solving technique, that would be explicit and implicit information. So then delta x is equal to, since it's a constant, that's nice, it's constant, because if it were not a constant velocity, then this problem would even be more difficult. But it's constant velocity, so delta x then is equal to, and we got to be careful because, we got to be careful because another way to think about this problem is, as opposed to thinking about two individual ships, one thing that helps me is it's like artists, where you think about the negative space. This R represents what I'm going to call the space between the objects. And it has this, if you were to think about like your hand, like say my hands are cars. And we're going to talk about this when we get to collisions as well. Let's say my hands are cars and they're passing one another, right? So let's say this has a velocity of 2 meters per second that way, and this has a velocity of 3 meters per second that way. So as the cars are moving, you can think about the space in between the cars as shrinking. So the space in between the cars shrinks to 0, then starts to increase the distance in the opposite direction. Well, you can think about that as two cars, or you can forget the cars and just think about the space closing. What is the velocity of the space closing? Well, it's going to be the summation of these two velocities. 2 plus, so this is 2, this is 3. They're closing, so they're adding. So the space is closing at a rate of 5 meters per second. Once it closes, is at 0, now it's going to be opening at 5 meters per second. And that's a combination of the velocities of the two cars. It's just remember, perspective is one of the themes of this course. This is an example why. Because for me, it's easier, once I understand that, it's easier for me to just think about the space and forget the cars. The same thing can happen here. This space is closing between these cars and it's changing direction, right? And it has, so when we want to look at its total velocity, its x velocity is going to be of how it's closing. Basically, this thing is going to be a combination of the x velocity of this thing and the x velocity of that thing. That's how much this thing is changing, right? Now, in fact, let me do it like this. Let's say that the total velocity of the space, I'm going to call it Vs. The velocity of the space is going to be equal to the x velocity of the space plus the y velocity of the space. And that's, but the x velocity of the space is how fast this x component is decreasing. Now, this thing doesn't have an x component. So the x component of the space is just going to be the x component of VB. Whereas the y component of the space is going to be a combination of the y component of B plus a y component of A. And it's a little bit counterintuitive. It's what I just said here. You might be tempted to think that because the cars are going in the opposite direction, one velocity is negative over the other. It is for the cars. But for the space, those things must add. And there's no physics, involved in that to say why. It's just logic. You just have to think about it. That the space is closing, right? So this even, relative to, I don't know how to say it. I don't even know words for it. It's just because the space is closing. I just know the velocities have to add. I'm at a loss of phrasing on how to say that. But now when it's opening, the velocities, I don't know, it would be negative. Is that true? Or do I have it backwards? Well, we can work it out here to see. But I think that when it closes, you would have to add the velocities, even though the velocities of the cars are in the opposite direction. Because they're always going to be in opposite directions, right? Like here they're opposite and they're still opposite as they pass. But there's definitely a change in the space. It's closing and then it's opening. So one has got to be positive or negative of the other. And I think it's positive when it's closing and negative when it's opening. So that's what I'm going to go with here. So I'm going to say that when these cars, when this thing is definitely getting smaller, so I'm going to add the y velocities of the A and B, and that's going to be the y velocity of the space. Or BYS, I guess. BYS and DXS. Okay. So that velocity is distance divided by time. So let me put in one more step here, though. So VS, the x velocity, as I said, is just going to be the VB cosine 35 VB cosine 35. But the y velocity of the space is going to be VA plus VB sine 35. Yeah, I'm going to go with adding right now when they're closing. Now, I've got to relate that to this equation 1. I'm going to go with component first. I'm going to say that velocity is distance divided by time. Yeah, so I'll do it separately. So I would say that the x component of the space is got to be equal to has got to be equal to VB cosine 35 times whatever time it, times the time, and that's a variable. So VB, in fact, we already know what it is, so I'm going to go ahead and put that in. We can put that in. So VB, well, actually, we'll do this step. So VB cosine theta, yeah, we'll put it in. So VBX, that's this guy, so that's 30.3 times T. And the Y component, Y of the space, is going to be the Y velocity times time. So the Y velocity is 22. Excuse me, because I'm running out of space. I'm not going to put in the units. Plus the Y component of B, which we determined to be, the Y component of B, which we determined to be 21.22, and then times time. So whatever time, if this is the velocity, whatever time it takes from 0, that's going to be how much the Y velocity has decreased of the space. So that's going to be Y of S then is equal to, what is that, 43.22 kilometers, per hour times time. Okay. I think that's it. I think that's going to give it to us. In order to get this function relative to time, we then need to take equation 4 and equation 6 and stick it into here. Do the algebra.
Oh, that's what they did.
Yes,
Oh,
yes,
that's what
yes.
they did. Okay.
That's going to give us the function that we have to minimize.
Oh. Now I understand.
Yeah.
I forgot that part. I could not think of that. Okay.
You
That's
know
what
what?
they did.
This is not a simple problem. This is an intermediate problem, and it's actually I appreciate you bringing this up in class. This is not an easy problem. It's easy once you know what to do, but it's basically it's kind of a calculus problem, but it's fair, because it's engineering physics, right? So, but some things like this, you just have to. I can lecture all day, but until you start working problems and do things, certain little things they come up, you just have to deal with them in problem. I know that these problems are difficult. I give it to you. I know that the Wiley Plus is, but one of the reasons I'm not going to change is because of this, because this is something that needs to be covered, but it's not. You don't even see this in your physics book, right? Because it's an application, and so a lot of books, don't really give problems like this, or they do, but it's in the, it's just, this is something that you know how to do, but it's not something. It's a combination of math and physics issue that sometimes people go through and they don't cover little things like this. But if you're going to be scientists, you need to at least be aware of it. So this is the second time all of you are seeing it. The first time was in calculus class that you probably don't even remember. Fair enough, because I didn't either. But now that we're doing it in physics class, I'm actually going to go through and have a little lecture on it, which is what I'm doing here. It's not just about getting the answer to this problem. It's also about what type of problem it is. Just a little historical fact. During, I think, the 16 and 1700s, this was like all the rage. When people figured out how to minimize functions, they were doing it every place. And there are certain physical concepts that we'll study later on. Like if you've had any physics course, like Fermat's principle, it's in optics, Fermat's principle and a couple other things, that's straight up minimization of a function. And so we'll revisit something like this back in physics 39 when we talk about light bouncing off a ray and the minimum point that you have to angle that you want to shoot is whatever. But there was, usually these problems are a lot more interesting problems. They're a little bit more for more advanced physics like junior level and senior level. But at this level, the sophomore level, there are certain problems that we can start to talk about it. And this is an example of that. So let me go ahead and finish up the problem, for those who you haven't maybe seen. But I'm glad you had a eureka moment there, Kimberly. I love those moments in students. But this is where it's coming from, right? So now I'm going to take that guy, put it into here, and then we're going to have our function that we can minimize. I'll kind of run out of space. So I guess you have the number, so I can erase all the values here. You just remind me of what those were when we get to the end. So maybe I can actually start this. So R, so I'm going to call this the R, I'm going to write it as R of T now, R of T. If I'm parameterizing, I think they also have that language in math with these kinds. When you have a function, it's depending on variables, which depends on another variable. Anyway, when I put the X in, I'm going to have 30.3 T quantity squared plus 43.22 quantity times T quantity squared, and I'm going to take that to this 1/2 power. So now when I square it, R of T equals, what is that, 900 something? We call 0 quantity squared. So yeah, 981. I'm gonna store that. Store to 980. Yeah, I'm rounding off here, but not on my calculator. So 919 T squared plus we call this guy square 450 T squared to the 1/2. I guess can I simplify that? I can simplify that, right? Yeah, if I can factor out a T squared and take a T all the way out. Can I do that? I can do that. So if I take it out, I'm going to have 919 plus 450. What is that? 1369? Is that right? 450 plus 919 is 1369. You know what? I'm not that confident. 919, 450. Yeah, 1369. So this becomes number.
Hey, Professor.
Yeah.
So you squared the 43.22 and it gave you 450?
Oh no, I think I might have squared something. Oh, did I? 43.22. Oh
Is that
no,
what
my
we're
bad.
doing,
You're
right?
right.
Okay.
Yeah, that is what we're doing. I put in something else. Sorry.
Okay,
Thank you.
okay.
Thanks for good catch. So 1867. Is that what you get?
Yep.
1867. Yeah,
Yep.
thank you. Good catch. 186. So 1868. So I'm gonna store that in okay, thank you. Good catch. So that plus the 919. So 2786.58. So if I factor out a T squared and add that, what I actually have is R of T. I think I can do that. R of T is equal to 2786 quantity t squared and all of that to the 1/2 power, right? So if I take the square of that, I actually have 52.8 times t. That's the function. So it simplifies it down to a function that's linear in t. 52.788 repeating times t. Everybody check my math on that. Make sure I'm not doing something stupid. I'm going to store that in my 4th register. Everybody in agreement with this?
Yeah, absolutely. Absolutely.
Awesome. Okay. Now, the thing is, I can see that if I take the derivative of that and set, so minimizing that function, so the derivative of that thing is just going to be a constant. If I set it equal to 0, that
Doesn't really give you anything, yeah.
no, it seems like I did something. Well, maybe is that the answer though?
Well,
Because
maybe not factor out t squared then. That is the answer for V, but maybe not, that's not part C. Maybe not just factor out t squared, maybe just raise it to the half like that.
could
I
you,
don't know, I'm
what
just
are
giving
the,
you a suggestion.
what's the questions, what does it ask again?
This is the part,
That
this
I
is the
should,
part that I'm having a problem with. So that's the thing. Let me bring it back up for you.
okay,
Let me share my screen, okay?
okay.
And then
It's asking for the time is the separation between the ship's lease. So
so asks us what time, at what time is the separation between the ships the least? And so the minimum of the function, and then it asks us when is the actual, what is the least separation? On a
Well, actually, let's see, because this is R, so like delta R over delta T is equal to a constant, basically, is what this is saying, 52.788. So, and if I graph that function, it's just a line. Like I could graph this function, it's just going to give me a line. Now, you said that there was some answer someplace. What is that? What were you saying? Kimberly, did you say
Yeah,
something
so I
about
was
something?
just trying to ask you that. That was my whole point of it, because I was struggling with this right here too. So you factored out T before the step you left, we have this vector, right? And I believe that, well, I think I know how to solve it now, because now I have the actual, what do you have here? 919. What is it? 919 t squared plus. So I think right from there, if I actually take the derivative of that and then raise it to a half, that will give me exactly what I'm looking for the numerator, so that I can figure out um, the first question that they asked, which was
So my question to you, Kimberly, is
at,
that at some point a few minutes ago,
yeah.
you said, I thought you looked at something and said that's the answer.
Well, yeah,
Did you do that?
that's basically B. We already been there. That was understood. That was we have that already. I mean, that's understood. I actually was like a little bit off, but I have 52 kilometers per hour right there.
Well,
But
my
that's
question to you
for B, I
is
believe.
what were you talking about? And when you say I don't remember what B was. What is B asking?
Oh, I'm sorry. Let me pull it back up really quick.
the Y components.
Yeah. Let me pull it back up real quick. So BX
so we
is
have that.
the Y
Yeah,
component of velocity.
right. So
And
we
A
have A and B. And then
Mhm.
part C is what is the minimum, the time at which the it's minimum. Is that right?
Yes, the minimum time.
The minimum time. And then what is the dt dx or
Then
dx dt? Dt dx. Uh, hmm.
and they have the
Okay.
RDT, just so you know. I could write it in the chat box for you if you want me to.
They
They
have
have the RDT. Yeah.
DRDT what? What about DRDT? That's not a complete statement. Can you tell me what you mean? What do you mean they have DRDT?
Let me just read. I'm like an action figure. Let me just mute myself real quick.
You were breaking up a little bit. Could you repeat what you just said? Hello? Oh, what is this? This is, oh,
Yeah, no, I'm sorry. I thought it probably like from this step where you just gave me whatever R is. I think from there we just need to so right there you
what
need to take
equation
the
are you
derivative
referring
of
to?
both
What
of those
equation?
numbers separate.
The equations are numbered.
This
What
right here,
equation
step
are you?
8. Step
Okay.
8. So you see we have step 8. So I
Yes.
believe from step 8, instead of factoring the t squared out, I believe that we should like derive from right there and then raise it to the half. That would give us our numerator when we're taking considerations for DRDT.
Okay. Maybe that was, I thought it would be the same thing, but maybe not.
And then we can set it to 0.
So
So I
deriving
do
instead of
understand you
taking
gave
the
me the
square?
whole problem when you told me that R equals x squared plus y. I forgot that block. So that was very important because I didn't understand how they were coming up with these figures, but now I do understand. So I think from there we just basically take the derivative of what you already gave us. I'm sure I can solve it now. Yeah.
Well, let's do it. We're
I don't
doing
know
it
if they
now.
have a
So
question.
I mean, we're doing
So
the
yeah, you
problem. So
just
let's
take
do it. So
okay, so
let's
I
do that.
think that all right. So I just believe that it's
So
probably
with that, you, like I thought you might be able to simplify, but maybe not. Maybe not. So this is going to be the chain rule, right? This is going to be the derivative of the inside. So if we did that, then we get, I'm going to do that over here. Because that's definitely not a linear function, I think, right? Because the linear function, that's screwing me up. That doesn't have a linear function doesn't have a minimum or a maximum. So maybe somehow there's something I missed in mathematically why you can't go from here to here when you're doing minimization. Thought you could. I didn't think we were going to get something linear, but anyway, um, if we take the derivative of equation 8, so let's make that equation 9, dr dt, you got to do the chain rule. So it's going to be 2 times 919 times t plus 2 times 1868 times t. That's the derivative of the inside function. And now the derivative of the outside to the 1/2, and then times the derivative of the outside function, which is this quantity thing to the 1/2. So that's going to be kind of running out of space here. So let me just go back over here, do this. So I need this now. So 9 TR T, T, that would be as I said, so 2 times 919 times T plus 2 times 1868 times T, okay, and then the derivative of the function, which is the function 919, is that true? T squared plus yeah 1868 T squared T squared, and that's so minus 1/2, and then what I'm throwing a blank here. I'm just having a bad day. So what the derivative of the function x of n dx is equal to n times x n minus 1. So then it's times 1/2. That's the derivative of that function. That's definitely the derivative of that function. So now we set all that equal to 0. And then solve for t. It looks like we're going to get a quadratic equation. So, doesn't matter as long as we can solve it for t. So 0 so I think the 1/2 goes out. That goes over you just multiply through by 2. Or there's a 2 here, so factor out. So that 2, yeah, because it's all multiplied, right? And this 2 can factor out. So that 2 factors here. In fact, I can factor out a t here. So I'm going to have 2t inside here, 919 plus 1868, okay, times that 1/2. I'm going to put it here, and then times all this stuff. 919 t squared plus 1868 t squared equals 0. So these two things cancel, and I'm going to get t times, what is 919 plus 8168? 919 enter 1868 plus the 2787. I think I've truncated that too, haven't I? I did. Let me put my, so recall 2, yeah, and recall 3 plus. So I'm going to store in 5. So 2786.5 stored in 5. And now all of that times this guy, 9-1. So I could factor out a t squared from this, though, can I? Yeah. I can factor out a t squared. So factoring out t squared inside here.
Professor?
Yeah.
The part you just factored out t squared, wasn't it with the power of -1/2?
Oh, thank you. Yeah, because that's going to give me 0. Thank you. So that's a mistake. All right. Thank you. Yeah, the -1/2 is up here. I forgot it. Thank goodness, because that would have been a problem. So, okay, yeah. So 919 t squared plus 1868 t squared to the -1/2 power. Okay. So this is equal to 0. So I can just take all that out, right? Yeah, I just divide through by this thing, this term here. I'm drawing a blank, folks. I don't know. I'm meant to have a bad day. So help me out with my math. Like, right, that's just A, that's like C times A plus B. Right. So I can just divide out by the C. Yeah, I can do that. So then that becomes basically 0 just equals this term. Right. If I divide both sides by this thing, then I'm just left with this, which is 919. Right? Am I right?
Yeah, correct.
Okay, good. 1868 t squared to the minus 1/2. Okay. So now, that's the same as so 13. So 0 over 1 over 919 t squared plus 1868 quantity to the 1/2 power. I can do that because it's to the minus 1. Now I can square both sides, right? I can square the whole thing. I can square the whole thing. That's just 0 still. And now this is, can I do that? Or is it t squared again? Well, that feels like a little funky. Maybe I shouldn't do that. But how then can I separate it? I can do, I can, I mean, it's equal to 0, so I can square both sides. I think I have to. I can do that. I'm trying to convince myself. I mean, it's algebra. So what you do to one side, you can do to the other. So I could, even though it's 0, it's just 0 square 0 is 0. I think I can do that.
Professor,
Yeah.
before we go too far, I wanted to ask about why did we get the derivative of number 8 in number 9? Why did we started doing derivative?
Because that's what you do when you minimize or maximize a function. When you want to find a local minimum, you take the derivative of the function and then find the quantity that minimizes it.
Okay. Thank you.
So if we're doing this right, this should give us a value of t, and that's going to be the time at which the r of t is a minimum, which is what C is asking us for. So I guess that whole speech I gave you in the beginning is that the way to do the problem, fundamentally, it's not a physics concept. It's a calculus concept. The maximizing and minimizing a function. And like what I've been teaching you is that the whole point I said on the first week or so, I teach concepts, not equations. So like you can't look at this and what equation do I use, right? It's what concept applies. Well, mostly it's physics concepts that apply. In this case, that's not true. It's a mathematical concept. And the mathematical concept is, I think there's a word for it, but I just call it maximizing and minimizing a function. But there's actually a mathematical term for it. I can't remember what it is. And the process is, if you have a function, you take the derivative of that function. It's during the time in calculus where a lot of times you had power functions, so it'd be like a curve, and then the top of that, like the curve is going to be a local maximum, right? And it's that value right there. So, and it's when you're taking, because the derivative is a slope, right? So the tangent to the slope, when it's a horizontal line, is 0. So what you're doing is finding the part of the tangent to this curve, and remember the tangent is the slope of the curve is a derivative. I know you can't, hopefully, because the colors are different, but if you know the functional formulas, it could be a parabola, it could be anything. when you take the derivative of it at a point, you're finding the slope at that point. But whenever that slope is 0, that's when the thing is at a maximum. Remember that? That's what that stuff is. Or it could do the same thing with a minimum. It could be the same thing. You're finding looking along the derivative at which that derivative, the slope of it is 0, but that's always going to be for a horizontal line. So that's where it comes from. The difference with those problems in this one is that they gave you the function. They just said, okay, here's a function, maximize or minimize it. Here, you have to figure out what the function is. So that's all that stuff I was doing. And once we get this function, which I think it's, well, if I haven't made a mistake, I'm saying it's this. So now we have to minimize it. So that process is taking the derivative of it, setting it equal to 0. Effectively, it's finding the slope of this function if we were to graph it at which that slope is 0. And it turns out that we can then solve for the value at that point. That's what all of this is. Does that make sense? Hello?
Yeah, absolutely. It's understood. I do
Do you
have
remember?
one question though. Yeah, no,
Do you
I have
remember
one
that
question.
now? Do you
Yeah,
remember
no.
that now? Do
Yeah,
you
I do.
remember that from calculus and stuff that I was saying just now?
Yes, absolutely.
Yeah.
Yes.
Yeah. Okay.
Absolutely. Yeah. No, I thank you. I thank you for like helping me remember that. I only have one question. I only have one more question in respect to this problem. Is it possible for us to at step 8, remember how you just factored out the t-squared right there?
Yeah. What's the question?
I hope this is not a dumb question yet, but why do we have 2
No
t-squares
question
from
is a
there?
dumb.
Why don't we have t-squared and t? Can you hear me?
Well,
Are you able to hear me?
I'm hearing you, but you're not. I haven't heard you finish the question. What is it?
Oh, okay, yeah, I just said from step 8, from your
Yes.
step 8 on the board.
Yes.
I'm just trying to figure out how we can get from, this is my only question. How do we need to derive it twice to get only 1 t? How do we set this problem up so where we only have 1 t, like instead of t squared? Because right now we have 2 t squared.
Well, it's the same t.
Uh-huh.
So it's a variable, and there are 2, but it represents the same time.
Okay.
Now, the answer to your question is what I had done earlier. I simplified it by taking the t out and taking the square root, but then I got a linear function, which didn't make sense to me, which made me feel like I was forgetting something or messed up somehow. That's what that whole point, that whole part of that was. And I stopped, and then I just went back to this. So the answer to your question is that you would just do the algebra, factor out the t squared, take the 1/2, and then you're going to get something. Whatever we had was like r of t equals 50 something t, and it looked like a linear function. But that's problematic to me for a couple of reasons. One, because a line doesn't have a minimum or a maximum.
Right.
And then I just went back to this because also you pointed out, so I forgot what you said, but you pointed out something about that maybe from a different point of view, and it didn't really make sense. And you were right. So then I just came back and I said, okay, well, let's just take the derivative of that and see what we get. So I'm in the middle of doing that right now.
Yeah, no, it's no problem. I had just actually, I understand what you're saying. Like I'll backpedal. I understand what you're saying. I was just wondering, like, how do we actually separate it to get t by itself? So that's my question. That's the easiest way for me to put it. Not even from that step, just moving forward. Like, yeah, how do we get t by itself?
Well,
even if it's like in the following steps, I'm just trying to figure out how to separate it to get like, because we have 2 t squares. Normally we have t squared and a t. Do you understand what I'm saying? Like normally we have t squared, t, and then t squared minus t. You know what I mean? So, but right here we have 2 t squared.
So if that's what you're asking, I mean, I thought it might be maybe that's what you're going from, because at some point in here I said I think it's going to be you're going to get a parabolic equation. I might be wrong about that. So I'm just going with we just need to solve for t. It may not be parabolic. And that's what I'm trying to figure out right here. So maybe that threw you off. If it's going to be parabolic, it should come out in the algebra, whatever it is. So I guess that's the best way I can answer that. It may or may not be. I thought it was going to be, and this is why I said that. But right now we're down to here, and I just need to solve for t on this. And for some reason, I'm like questioning as to how I do that. But I think, I mean, certainly if I had a constant over here, I would just take the square root. Somehow the fact that it's 0 is making me a little bit, I don't know, can't do algebra. I'm going to take the square root of both sides. And so that is the final. If I do that, that will be the answer. But see, isn't that going to be, yeah, that's still going to not give us, that's going to still be 0. Right? It's still coming back to what I had before, which is that, yeah, that is right. You just take the square root because I could factor out a t. That's going to take me back to what we had before. Yeah, so I can add those two things. Yeah, I think I must have done something wrong. I'm not sure where. That's just going to bring me back to what we did before, which was that whenever I just factored out initially, recall this plus, yes, you get 2786 t squared. And yeah, if I take the square root of that, I'm going to have 5278 times t. But that equals 0, so that's just going to give me 0. So this term here, was that a mistake? Position equals velocity times time. Theorem. Yeah, that just leads to what I had before, which is
Professor,
yeah.
before you raise, I wanted to ask about the questions A and B.
Yeah.
Just
Go ahead.
wait a second.
Okay.
So the question A and B are asking for the x and y of A, the velocity of A relative to B. So well, how did we get them? We just got the velocities of each. Aren't we supposed to, let's say, if the velocity of a B in y direction is this number, we get the velocity of A and compare to velocity of B. It's
You
hard
would
to explain. Yeah.
you would add the velocities. It's this equation here. And I didn't actually put you're right. I didn't actually put the numbers. I thought it was actually asking for the individual velocities. But if it's asking for the relative velocity, v relative to a, then the x component of that velocity is just this thing. But the y component is going to be the negative. It's not the sum. The y component, one relative to the other, is one is going at, you can tell me, I erased it. You can tell me, I can put down let's just put them down again. Just tell me what they were. I said VBX was what? So
I don't know. I
VBX,
was doing with different values. If somebody else could give you a answer.
oh, I see. Okay, well, I'll use these again. VBY was
VBX 40 costs 37?
VBX I don't know if it's 40.
VBY, oh, I'm just doing the one that it's showing in the book. I don't know which one you're. What's
I think
the
the numbers are different. Kimberly, can you tell me again what those numbers were so we can stay consistent with what we had here? What was VBY was well, VBX is 0. So VBY is, what is it? It's VB times the cosine of the angle. The angle was 35, but what was VB again? For
Now
your
we have
numbers?
30.31 minus 21.22. Oh, I'm sorry. VBY with 4 minus 4.43.22. Victor J, right? I'm sorry, what's your question?
The question is, what is VB? So I know that VBY was VB times the sine of 35, but I don't remember what VB was.
It
If you
was
could just tell me
37.
that.
I remember it was 37.
37
the
sine
initial velocity.
35. Yeah, he's
So
right.
37 enter 35 sine times. So 21.22 was VBY.
Absolutely.
VBY is equal to 21.22 kilometers per hour. Let's just go ahead and do, and so VAY was equal to negative 22.0 kilometers per hour. So who was asking me about the relative velocity? I didn't look at the name. Whose name was that? Oh, Hayek. Yeah. So that if they're asking for relative velocity, the relative velocity between them would be the difference in these two, or the sum of the two. So actually, no, the sum of the two, not the difference. So the velocity of one relative to the other is going to be the 43.22 kilometers per hour. One is because they're going toward one another. Then this one looks like it's going 43.22 kilometers per hour south relative to this one. And this one looks like it's going 43.22 kilometers per hour north relative to this one. So the y component of the relative velocity would be 43.22. The x component of the relative velocity would be just the x component of this one because it's the only one that has x component. So let me, I'm going to put that here. So, yeah, so I've been calling that V space. Let's just call it the components of the space between them, the velocity of the space closing and opening between them is also the relative velocity of one boat relative to the other. So the y component of that is 43.22 kilometers per hour. And the x component of that was whatever the x component, was it 37 times the cosine? Is that, we said VB was 37, right?
Mm-hmm.
We'll say So 35 cosine times, yeah, 30.33. So the x component is 30.3 kilometers per hour. So the relative velocity, which you call v relative, is going to be the Pythagorean theorem, the square, let's square that, 43.2, square that, and then take the square root of all of that. That number should be the relative velocity between the two, the total relative velocity. Does that make sense?
Mm-hmm.
So I think since we took those numbers, I messed up, I must have misread the question. I didn't realize it was asking that. But we can calculate this number, and Kimberly, you can tell me if that's the answer that is the appropriate answer for whatever it was, A or B or whatever it was. So square that, and then we call another day. So I need to take a quick break. I'll be right back.
Professor, wouldn't you need to consider the initial location of the ship? So wouldn't it be 2.5 minus 30.3 kilometers squared plus 43 point or yeah, 4 minus 43.22 kilometers squared, and then you take the square root of that?
That's not velocity. That's the distance between them. That would give you R.
Give you it would give you the magnitude, wouldn't it?
That is distance. That will give you the maximum distance between them. I thought he was asking about relative velocity.
I was saying for the question, I think it was asking magnitude. Was it?
Again, magnitude is not the issue. It's relative. It's are you looking for distance or are you looking for velocity? He asked me about velocity. I thought you said relative velocity between them.
X and Y components of the velocity of A relative to B.
Yes, that's velocity. Raheem, what you were just talking about is distance.
Yeah,
Those are two different things. So you're right.
So it would just be the 30.3 I minus the 43.22 J, and that should be okay.
Well,
yeah, I typed it in the chat box for you. I'm sorry, sir. I just want to let them know I typed that in the chat box a little while back. So I think we were like past that point. But he was actually trying to figure out the minimization. That was the problem. I don't know what he had asked you, but
yeah, that's what I was doing. I was trying to find the like get to the answer.
So we're kind of mixed up here. We're talking about two things. I was dealing with Hayek's question, and Hayek was asking me about relative velocity. So that's what this is. Have you changed and you're talking about something else now, going back to the original part C or whatever? Raheem, I'm just lost.
Oh no, carry on. I think my mind is in another place. I'm on a different page.
Okay, but Raheem Hayek had just asked me about the relative.
Yeah,
Could you put the question?
I was differentiating the problem and trying to solve for the minimum value. So I guess he had asked a different question, but
Yeah.
I was just trying to complete the problem.
Okay, that threw me off. Like, so you
Yeah.
might be right. I have to go ahead. Let's go back to that once I answer this. But
Uh-huh.
but right now I'm asking, are we in agreement about this thing?
Yes, for the
Can,
relative
can you
velocity.
put up the question again? Can someone put up the question again?
I can share my screen. It just with different values.
That's fine. That's fine. We'll stick with Kimberly's values.
Okay, I will go ahead. Okay, it's these values.
So what question were you asking about? This part A, or what are the
A.
X component and Y component of velocity A? Oh, I didn't catch that. A relative to B. You're right. You're right. I was just, yeah. So that part is, you're right. So here, what I'm doing here gives the total velocity relative to one another. But they're asking for the component, which we did because we've already done. That's actually the components of each. So like the X component of A relative to B is just going to be the 22, no, sorry, whatever, this thing, the 30.33. That's the X component. So the X component of the relative velocity is going to be 30.33. That should be the answer for Kimberly. And the Y component, it should be this thing, the 43.22. So Kimberly, is that what you get for answers A and B? Are these, or is that what you put that up here? Is that, what are the answers that they give for your A and B for yours?
My or Kimberly's?
No, Kimberly,
Kimberly.
because we're using Kimberly's numbers.
Yeah.
Kimberly, are you there?
I'm sorry, you can hear me now? Okay.
I can hear you now, yeah.
Yeah, okay, sorry about that. Absolutely for A. I already typed it in the chat box. I keep telling him that. So I typed.
Yeah, but what I see here is 20.2.5 minus 30.31. That's not what I have here. And I don't understand and that also, is that a velocity? It doesn't have that's the velocity. That's what the answer is for the velocity component.
For the magnitude of R. That's for question B. C, I'm sorry, C, the beginning of C at least.
I'm
The
asking
magnitude of
about
R is, the magnitude of R is 2.5 minus 30.31. It's supposed to be squared, and I was trying to write it on exactly right, but yeah, you need to still square it and put it under the square root sign to get the magnitude. And we were past that part. That was the beginning of it. It was the part after that, getting the minimum of this function. That was the hard part. So I don't know. I hope you understand what I'm saying. Like, I hope I'm not.
I'm asking you a simple question. The question is this: what answers does your problem give for parts A and B? That's what we're doing right now.
Oh, okay.
And that, I don't think that's in the chat there. That's something else.
Yeah, so
we're asking about
for
parts
vector
A
AB
and part B.
Yeah,
Yes.
for vector AB, that's correct. Is what you have up there, the 30.3 and the 43.22, that's correct.
So you have the same numbers as she does? I thought it changed numbers.
No, I don't. I'm looking at what you did and basically, yeah, for the velocity, relative velocity, that's what you would do is vector AB, and that's the 30.3 kilometers and then the 43.22. I think she's just on the next step, the one after that. That's part of C. So because like B leads it into C, so that's kind of
I
the
un-
same thing I was
I,
doing.
I understand that. I'm just simply wanting to confirm that I didn't make an algebra mistake and that we actually got the same numbers for part A and B, because I think you can see the answers, can't you,
Yeah, it's
Kimberly?
negative 30.31 for the I vector and 43.22 for the J vector. Or you might have an X and Y, or no, same thing.
So could you repeat that again? For the X vector is what?
30.31,
Okay. And for
Mhm.
Y is what?
43.22.
Oh, okay.
Okay.
So good. Thank you. Appreciate that. So that confirms that that is how to do the relative velocity. So you good with that, Hayek?
Yes, absolutely.
Hayek? Because you asked the question about that specific.
What was it?
Hayek, are you?
I was not that there at the moment. What was it?
She just said, Kimberly verified that these are the right answers. This is the
Yeah.
velocity, the relative velocity component for X and the relative velocity component for Y. So you're good.
Okay, thank you.
Okay. Now, Raheem, you had said something which suggested to me that maybe I had missed something. What were you saying? Let's go back to now part C, which is minimizing the time, which is what you had. What were you saying, Raheem? Sorry, about earlier. You had said something which made me
Yeah,
feel like
was to add the initial like the position, the 4.0 kilometers and the 2.5 kilometers east, and subtract those from the subtract the vectors A and B from that.
oh, the initial positions. You're right.
Yeah, so the 4 kilometers north and the 2.5 kilometers east of ship B, we'll have to factor that in to get the answer. And that's what was missing off of the
that
initial.
is
You
missing.
remember when you were trying to solve it
Yes,
without that? That's what you were
yes,
missing.
yes, 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 yes. Thank you so much.
No
Thank
problem.
you.
No problem.
Yeah. So, and I'm going to go back and speak to you specifically, Kimberly, because you're the one that asked the question, just how I do. This is wrong. I mean, it's not completely wrong. It's just not completely right. I forgot to put in the initial position, the initial distance R. And the way you do that with the parametric equation, it's so stupid. Yeah, it's just a stupid error on my part. Sorry. That's what's wrong. That's why we basically get 0 down here.
I
So
don't understand. How is it wrong? You have from 7. It looks correct. You took the square of S. Go ahead.
what we did was not incorrect. It's just that not everything is here. Let me say it that way.
Okay.
This is an R of t, but I have more information. I know what the initial value of R of t is. It's this distance. So I need to put that in and I think that's the thing. That's the point that I need. Then I have to minimize it. I forget how to write this mathematically, how to explain it, but Raheem is right. It has to be in there. And so
maybe you can write
basically,
what I put in the chat box. Maybe that's what you're looking for. This block of code right here, 2.5 minus 30.31 I plus 4 minus 43.22
That's
J.
that's the one. Yeah,
That's
it would
it.
be squared,
it.
and then you take the square root. Yeah.
Yeah, absolutely.
I think that is it. So yeah. So what I have to do though, I can't just because you got that from that's what they had in the book, right?
I just took the time and variation between.
So you made this equation that you wrote there?
Yeah, I've been wrote it about an hour ago. I've been
I
trying
know
to tell
I know you wrote it a while ago. What I'm asking is where does it come from? Did you derive it or is it something that you saw in the solutions?
No, I really derived it. I just took the time in respect to both of the vectors. So I got kind of differentiate right there. I didn't set it to 0. I know that you're supposed to square both of these numbers to get what you actually looking for. I didn't even take it that far. I was just trying to basically figure out where I was going. So I'm just keeping
Okay.
it
So how do you? That's cool. I definitely want you
Yeah.
to do that. I want to be real. But how did you figure that out? Like, how did you come up with that?
Well, because you gotta have 2 points, right? For you need 2 vectors for I, 2 vectors for J. I mean, that's just what
So
it is. Like
what I would
in
also say
respect
is
to
that
time, that's I'm sorry to keep cutting you off. You need to make sure
I'll
that
cut you off.
it's in respect to time. The vectors are in respect to time, both of them right now. So that's how I came to
Okay,
this conclusion, if you're asking me that.
but time is not in here in the equation, right? So I don't see how and also that's not an equation. It's just it's a
Well, the data
phrase.
point that they gave me, so they give me here, I set it up a little different. So I have it like D1, D2, D3, D4. I'm sorry about that. So I needed,
Don't
yeah,
apologize.
that's
You
how
don't
I
have to
set it
apologize.
up. So
But you
I'm
understand
sorry,
what I'm
KM.
saying?
I'm sorry. Please
This
tell
is
me
not
the
an
question.
equation. This is not an
Mhm.
equation, right? So I don't understand what that phrase is, which is I didn't see it initially, but then when I did
Mhm.
look at it, what you pointed out, I didn't quite understand what it was. And even now, I guess I do now. I can see where because I've done here, but like that's not an equation. So where is time in that, and what does it equal? What is that? You know
No,
what I
it's
mean?
not time. It's actually D1 kilometers or KM. It's my KM value.
So
So what
what
I
does that
did was,
equal? What does that equation equal? What is it? Because that's not an equation. It's just a phrase. You understand what I'm saying? So I'm trying to see like what is that? Well, what are you? How are you using that?
this is our vector in respect to for the magnitude. This will give us the magnitude because it's our first value of let me see. Let me just bring this up real quick. I'm gonna bring up the problem real quick so I can tell you.
Okay, I think I got it. I
Yeah,
think I
let me
got it.
see real quick. I'm gonna tell you.
I'm asking you a question. I'm not sure that you understand
No, I'm trying to answer it
that
for
you
you.
know the answer.
I'm trying to because this the way that I solved it was I told you that I use ODE a lot. So I wrote it like D1, D2, D3, D4. I wrote all my values like that. And
Let me ask you a different way. Let me
I
ask you a
moved
different
forward.
way. What is the 2.5? That 2.5 represents a position, right?
Right, which is I'm trying to bring the problem up, but if you bring it
Okay,
up, I
got
can
it.
tell you.
That's fine. Just listen, just answer my question. The 30.31 represents a velocity, right?
Yeah,
Right? So
yes.
that doesn't make sense to me because you can't subtract a position from a velocity. That's the point I'm trying to make. However, you are absolutely on the right track. And I think I got how to do it now, how to do it, and all because I also made a mistake, but also how to fix it and make it consistent with what you have here. Very good what you did, but that's the problem. And
KM
that's why
North.
I didn't really understand it. When I saw it earlier, I didn't know what it was, but now I do. And you're right, you were almost there, but what you weren't doing is what this whole deal that where I define it. But I think I can match the two, and so we can all be on the same page. If we can all understand it, and then when I then minimize it, we'll get the right answer.
Right.
So let me show you. I'm going to erase all this because there are errors in that because of the mistake that I made early on. So you're right. This is right, but I didn't finish. I need the initial position, and this represents in terms of velocity, this distance, right? Because that's like if I had whatever the right time it is, I guess maybe, I don't know how you would call it, but, this right side of this equation, I think is representing, R at any given time. So that's one way to represent it in terms of basically the velocity and the time. But the other side over here are the components of the actual vectors, as I started pointing out along the x and the y position. Basically, it's delta x. So basically, let me square it again. So if I square it, I have basically r squared equals this term 919 t squared plus 1868 t squared. But the r squared is equal to x squared plus y squared. And I think that's where we're going to get the equation that you have there, although I think you left out the time on the right side over there, I think. But let's see. So what we're going to get is this component we said was the x component. So that's x squared. And that initial position, x, is what is it? The delta x is, I'll just use absolute value. That was the 2.5, right? Yeah. So 2.5 kilometers, I'll leave out the units. 2.5 squared plus the y component initially, which was was it 4.5? I don't remember the numbers. Can you tell me again? What was the initial position of the delta x? Was it 2.5 or I guess I have it here. So that was
It was
2.5.
for y 2.5x in
For
Kimberly.
X 2.5, for Y 4.0,
One more time, please.
for X 2.5, for Y 4.0.
Okay, so 2.5 squared and then 4.0 squared equals 919 t squared plus 1868 t squared.
Okay.
So now, yeah. So now that's going to give me something that when I minimize it, I'm not going to get 0. So let's try that. So whatever this number is over here, yeah, I think so. I don't know. I think that's right. We'll try it and see. If not, I might have to just try to figure that out on my own and give it to you later on. But anyway, yeah, that is going to be the original because I think that sets like an initial condition that sets up the function. I think we have to have it. That's what's missing. So let's yeah. Um yeah, I guess I didn't even have to square it if I was going to do that, but I can just go ahead and it should give me the same answer now because I have squared it. All right, so square 2.5 squared 4. So we do need those initial conditions, but I'm not sure that just putting it in like that is the right way to do it. Let's look at the X component by itself, because that's how I started. So
Yeah,
X,
but I think we can, not to cut you off or nothing like that, I'm just trying to help out. I
Go ahead.
think we could take, the constant from position gives I and J. So I believe that, like I said before, that I wrote, let me see, let me scroll up right here on the chat box to the right. Let me scroll up right here. Okay, so, yeah, constant from position should give us, should give us our I and J vector. And then squaring from there, we get the magnitude. Right, because we already have our X and Y value. We have that, right? We know that that's given. We got, we saw for that. So that's understood. 30.31 and 43.22. And we have these constant 2.5 and 4. So we should just be able to integrate them, right? To obtain position. That's what I'm trying to say. And then squaring will give us magnitude, just to make things simple.
Can you just write it out and tell me? I can't really follow when you're saying it like that.
Sure, I think he wrote it already.
Is
but
that
I'll
what
write it
Rakeem wrote?
again.
Is that what Rakeem wrote here? So
Yeah,
that's
so
what you're
he's a
saying?
little ahead of me. I think he was trying to get the magnitude. He might, but this is what I
Yeah, so
wrote earlier.
that would be the equation. And then once you take the derivative, you'd set it up as dr over dt. And then you would go 1/2 times like the derivative value over the square root of what we just wrote, the magnitude.
Okay.
And then set that equal to 0, and that'll give you the answer.
Awesome. So yeah, okay. Fair enough. So I'm gonna just write it out in the components here. The X component you're saying is it's gonna be
Our whole I vector in respect to position, which is 2.5 minus 30.31.
Well, it's not minus 30.31, it's minus 30.31 times t, right? That's what you had missed before.
Yeah, 30.
Agreed?
Yes, yeah, absolutely. Yeah, absolutely.
Okay, got it.
Sure.
Yeah. And the Y component is going to be the, was it 4.0 minus the relative velocity, the
43.22 T.
Yeah, 43.22 T. All right, cool. Awesome.
Right.
Awesome. Okay. All right, good. So then now R, because R is equal to X squared plus Y squared, R of T, we can put all that, okay. All right. So yeah, I missed it in the beginning.
Okay.
So X of T, awesome. And I didn't understand what that was, Kim. I can't read numbers like that. I have to read, or I would have probably, it might have helped me realize it earlier, but I just didn't. So I apologize about that. And thanks for asking, Hayek. So X of T squared plus Y of T. I want to write it like that. So yeah, R squared, R squared. So now putting all that stuff in, we have R of T. The function that we have to minimize is actually going to be this thing, 2.5, which is what you've written up there, minus 30.31 times T, quantity squared, plus 4.0 minus 43.22 T, quantity squared. And then it's that whole thing that we have to take the square root of, that we have to minimize. Agreed? Are we all agreed?
Agreed.
Okay. This time when we minimize it, we definitely will not get something that doesn't make sense. Because we're going to have these, I can see it. We're going to have these constants over there, and that's what was missing. So now that we spent all this time on this problem, I can't leave it. We got to do the problem and get the answer. So I think you have that. You actually have the value, right? Don't tell me, but you do have the answers, right, Kimberly? First, because basically there's two unknowns. There's R and T. So the reason they're asking you is once you minimize and find T, then all you got to do is plug the T back into this equation, and it's going to give you the R, the distance. Does that make sense?
Yeah, it does. That makes sense.
Yeah. So let's I'm not going to, we spent all this time on it. I'm going to do it and we're going to get the answer. And then actually it's kind of good because this pops up over the next 3 courses at various points, this idea of maximizing and minimizing a function. So even though we spent a lot of time on it, probably more than I would have wanted to, still, it's actually because not that it's a problem that you asked, it's a problem that I was kind of rusty. And I was kind of just had some stuff going on before class, which is why I was late and I was kind of in a space. I wasn't really prepared when I came in here to teach because of some stuff. Anyway, I just made a mistake and I admit all this. So it's not your fault. It's my fault. I should have done this faster. But it does give us an opportunity to review that because that's something you got to know. And it's not something that's really specifically a physics concept, which is why it's not actually in the book anywhere. It's calculus. Anyway, let's go ahead and do it. So, well, now we got like a double chain rule, right? Because we got to do the chain rule inside of this thing, and then we got to do the chain rule the whole thing. So that's actually a pretty good review. So I guess we don't need this anymore. We don't need that anymore. Let me just give myself some new space. So let me see if we can do this because there's going to be a bunch of algebra. So I got to take so 1, 2, 3, 4, and so let's start here. So 5. The derivative with respect to time of R of t dt. Okay. Well, let's first take the chain rule. The chain rule is the outer function. So all of this I'm going to put in brackets. So the derivative of that is going to be 1/2 times all of that to the minus 1/2. So I'm not going to write all that stuff. Now we got to take a derivative of the function, but the function is also an embedded function and there's 2 terms. So we got to now take the chain rule of this thing. So, and all of it's multiplied, right? So the chain rule of this thing is 2 times that guy times, like this is the 2 is the n, so it's 2, and n to the minus 1 is 1. Now we got to take the derivative of the stuff on the inside. This is a constant. The derivative of that is 0, and this is maybe I should have multiplied it out. Hope I'm not messing up. I could multiply the inside term, and then it would be a straight derivative.
Yeah, I multiplied and added first, and then I did the differentiation later. So if you multiply the inside terms, you get 2786.66 45 t squared.
Tell me again, please.
2786.6645 t squared.
Actually, you know what? I'm gonna go ahead and do that down here before we get up to before we take the derivative. I'll just go ahead and do it down here. So R of t then is equal to And then over here, that's going to be plus 16, then plus 172.8, and then that's minus, that's a t, and then plus square of that, which is the 1, 8, 6, 7, 9, whatever, t squared. And all of that to the 1/2 power. So what you were giving me was you had added all that up, right? That's what you were giving me?
Yeah, I'd added all that up, and then I differentiated.
Let me just make sure we're on the same page. So you got 22.25 in there. The t terms. Minus 48.65 times t, and then the plus call 6, we call 1 plus something like 2786.58 t squared, all to the 1/2. So this is what you have? Something like that?
Yeah, you got it.
Okay.
Oh wait,
Yeah, that's good.
I got something with the T term. I wrote it in the chat. It's minus 497.31 T, and then you differentiate, which gives us the R, which is 5573.329 T, minus 497.31. That T drops off, and then the last term we don't need it. And then we put this dr over dt, which is the dt would be the square root of 2.5 minus 30.31 squared, 30.31 t squared over, and then you set that equal to 0, and then that'll give you your answer.
Yeah, before we do all that, I just want to verify that this step right here.
The squared term is correct. The term in the middle, the t, something's missing.
And what about the constant term? I don't see the 20, yours is 22.25.
Yeah, 22.25. That's on the top before I differentiated. So when the R, I got it from differentiating the term after I did the math for the stuff on the inside, which is the stuff on the top. It's 2786.6645 t squared minus 497.31 t plus 22.25.
Okay, okay, cool. Well, let's just, I want to do this verify because I don't know where I did wrong. Did I miss, oh, maybe I left off the 2.
Yeah, I
Is
think
that what
you
it,
missed
I,
one
I missed the 2 for each term.
FOIL. Yeah.
Yeah, FOIL. So 248, 248, exponent 2 times. Yeah, that's where you're getting the 497. You're right. I left off the 2 on the FOIL. My bad. Anyway, yeah, so okay, 497. 497.3. Yeah, 3. L4.1 or whatever. Okay. Okay. So, okay. I will do it just so everybody in classes, because not everybody's participating. It seems like only 3 people, Kimberly, Raheem, and Hayek. So I will do it out, but you've already done it and you got a value for T, Raheem? I mean, sorry,
Yeah,
who was that talking?
yes.
Was that Hayek or who was talking just now? Oh yeah, Raheem, yeah.
Yeah.
What'd you get for T?
Uh, 0.089.
0.089 seconds?
That's in hours. 0.089
Oh,
hours.
hours.
Or
Hours, sorry. Yeah,
yeah.
you're right. 0.089 hours. And what did that give for the minimum distance?
When we plug that back into the original equation, it gives us 200 and or 0.25 kilometers.
0.25 kilometers.
Yes.
Now you use Kimberly's numbers, right? Or
Yes, this is
yours?
from Kimberly's numbers. Yeah, mine is different.
Okay, Kimberly, can you verify that these are the answers for C and D?
What you want me to do? How you want me to test it? I mean, I
I
can.
thought
He's right so far. I'm just saying. I'm sorry. I'm not trying to be argumentative or anything. He's right. Everything that he's telling you, that's correct. Are you just trying to get me to see like if the software will accept it? Is that what you're asking me?
no. I'm asking you to simply look in the book to see if that is the answers, the correct answers.
Oh, we don't
Because
have no
that's
book, boss. This is from the software.
so. I thought that once you give the answer to the question, like once you turn in the answer, like I thought you had the answers. Like it tells you what the correct answers are for
Nah,
your
boss.
particular problem.
Nah, we test it, and then if we get it wrong, they let us try again. You do understand that, right?
I understand that you get 3 trials, but I also understand that it's set that once you after your final submission, it should tell you the correct answer.
Yeah, I think it does on this one. Like if you submit it, because there was a few questions that I got wrong. And when I look back, it does give you the solution afterwards.
Okay,
Yeah.
I haven't got that many wrong, so I don't know. I didn't know that.
It doesn't matter whether you get it wrong or right. Once you submit the answers, it gives you the solution.
No, it does not. They let you try again, so you get because I haven't got that many wrongs, but
So it gives
I've
you the
tested it
solution.
2 times. After 2 times, I've been right up until this point.
Kimberly, after the third time, like if you get it wrong, because like on a few of them, like I said, like I got like one segment wrong, and then after the third time, it won't allow you to enter the answer again. But when it'll open up another tab that says correct answer right next to your answer, and when you click on that, it'll give you what the correct answer should have been or would have been.
Okay, that's fine, but I don't have a way to test that out because I'm not gonna risk. I'm not gonna risk it. I don't have a way to test that out. If you understand what I'm saying, like I'm not
Trust
gonna
me,
go in
Kimberly.
there and get it wrong 3 times. Or I mean, I could test the solution that he gave out. I could just put it up like that. You know what I mean? But
Can
I
I?
really like. I like to
I
go over the
understand.
data myself again, if you don't mind. I'm sorry. I'm not trying to be argumentative here. I'm just saying if I'm gonna take my chances and my risk, I'm gonna actually work the problem out again, make sure I'm right, because I usually work it out about 2 or 3 times, then I submit it. So that's how I'm able to not have to keep testing, keep querying the computer, if you understand what I mean.
This assignment, this is for this is assignment that's already been turned in.
It's
Is that
for
right?
Wiley.
Homework,
coming up.
on chapter 4, homework 2, 2D motion,
Yeah.
question 20, I
20.
think.
Oh, so it's not due yet. I can't remember what the due date is.
It's due today.
It's supposed to be due today.
Okay,
Yeah.
got
If you
you.
could give us one more day, I would appreciate it because it is kind of difficult. Got 10, we got only maybe maybe 7 hours to get 10 problems. I mean, that's a lot, but I don't know, maybe they finish. Me, that's what I was just telling you. That's why I think I've only missed, like, out of all these problems, I've only missed maybe 1 or 2 out of all the problems that I worked out. So I didn't really know that they give you the answer at the end. I hope you understand what I'm saying, Professor.
I do. And so now you know that it's set to, but you're right. Like you have to basically finish all your trials first, and then whether you get it right or wrong, it gives you the solution. So just for everybody, because I can't see it from a student point of view, so I thought that was it was obvious, but it doesn't matter. Like now you know, and so that I do set it up to do that so that you have the answers once you submit it, once you've given your final submission, so that you know. And because there was an issue, I think the first day or someone was asking me, and it didn't look like it was doing that. I can't remember whether that was this class or my Physics 38 class, but that didn't look like it was working out right. So if that is glitching, let me know, but it shouldn't. Once you submit your answer, it should give you the right answer. So that
that was this class. On homework 1, it didn't give you the correct answer afterwards, but this time around, I noticed that if you get it wrong on the 3rd try, it'll open up the other tab with the correct answer.
Okay. Yeah, I don't know what was going on with homework 1. I never was able to figure that out. Like I haven't done anything different, and it's set to do that. So who knows? I don't know. But at least it's working now. And yeah, Kim, I'm sorry, Kim. I thought that you had already turned it in. I didn't know, like, because so you wouldn't see that. And I don't want you to test an answer and get it wrong just to give me an answer. I thought that you had already done it. So my bad on that. And
No,
it's
I
fine.
didn't, boss. That's all. I just wanted to be sure. That's why I always, when you ask us questions in class, I always say testing. I'll be joking, but I'll be serious. That's how I get down with this. I like get out, even from a data science perspective. I get the data from everybody. I hear other people's perspective. So I'm not only one of those, I'm always right people. I'm not like that. You know what I mean? I'm pretty much listen to everybody, hear everybody out. I look at all the facts. That's why I said I'm gonna work this problem out again, and then I'm gonna get my submission. So I haven't missed 3 times up until this point. Remember, because the only reason why my grade is like that because I ran out of time. Yeah, I haven't missed that many to even know that. I didn't even know that.
I haven't looked at your grade, but okay. But so since you spent so much time on it, I want you to get this problem right. So that's why I want to check. So I'm going to go ahead and do it now, because the only way now is for someone else to do it and verify that you get the same answer that Raheem got. But since you spent all this time, I definitely don't want you to put in the answer for whatever reason and get it wrong. So let's go ahead and I'll do it now, and hopefully if I get the same answer as Raheem got, then that suggests that. Definitely, I'm confident that this is what I was missing earlier. This is why I didn't get the right answer earlier. Now that we have that, for me anyway, that's not the only problem for me. I have issues with numbers, so I want to do it and make sure I get the right number and don't make a careless error. So let's continue. So now we want to minimize. So this is the function, and you can see, like that's what I was saying earlier, Kimberly. Now I can. It's a parabolic equation. So I should have gotten it. I didn't before. Like I know it's squared, but like it's not necessarily a parabolic. It's going to be a power function, but some sort of power function. When you get in, it's going to be a curved line, whatever it is. So it's going to have a maximum or a minimum. That's why when I got down to the thing before and it was linear, I could mathematically see that something was wrong because a line doesn't have a maximum or a minimum. It just goes on forever. That's why we were getting that nonsense. But it was because I forgot the initial condition, which gives the initial space, because that's kind of, it's like it sets a parameter. Like when you get, after you've had ordinary differential equations. The reason why I give all these kind of soliloquies or whatever is because one of the things that I like to do in this class is kind of bring things full circle. And a lot of times you don't have that unless you have an applied math class or unless you take a physics class. And this is the class of all the 3 courses, this is the one to do that. So you had talked about taking ordinary differential equations.
Right.
In the first chapter, the first week of ordinary differential equations, it defines something for you called a family of curves, right?
Right.
And when you solve that family of curves, you have to have initial conditions that then when you get that, you get the differential equation, and then you apply your initial conditions to that. And what that does is when you solve it, it allows you to get the specific constants for your specific situation.
But that's a situation, correct?
It picks out of all the infinite family of curves that
Mhm.
applies to a particular differential equation form, the
Mhm.
constants pick out the one equation out of all those infinite equations that applies to your physical situation.
Absolutely.
That's what initial conditions do. So what I had done is kind of a couple of mistakes, but set up an equation and I didn't put in the initial conditions. The
Mhm.
initial conditions were those initial distances that set the initial distance.
Okay.
So when I put that in, that completed the differential equation. And basically now we're not solving it, we're maximizing it, but that's what was missing. Because that was giving kind of, whatever, it's a family of possibilities, but there's only one possibility that I need for this point, the possibility that's set up by the initial conditions of the original positions of the boat at time t equals 0. So
Right.
that's what was wrong. Okay.
Okay.
So now let's solve it and get the final answer. So or maximize it. So taking the dt again, it's the chain rule. So I got the 1/2. I'm just going to put that stuff there, and then now to the 1/2 minus 1 is minus 1/2, and now the derivative of the stuff on the inside, which is easier to do now because it's just each term I can do with just the basic rules for differential. This guy is 0, right? Because it's a constant. This guy, the derivative of that is t, of t is 1. So that just gives me minus 497.31. And then this thing is 2, to the t minus 1. So that's going to be plus 2 times that thing. Well, I just put it out like this. 2 times 2, 786.58, and then to the t minus the first power. And sorry, t to the first power. Okay. So now I got to go back through and then I set all that equal to 0. So just t. Okay. So this stuff is inside here. So I can just multiply all the terms together. This constant term and that constant term multiplies. So I'm going to have 0 equals whatever that thing is. Here's my calculator. Really? No. Okay. So I can't do that because that's to the minus 1/2 power, right? What is this? There's 1/2. Write this out so I don't get confused. 25 minus 4 times 7.31t plus 2786.58 t squared and a minus 1/2 and times minus 497.31 plus twice that, which was 5573.16 times t, and all of that equals 0. Did you get something like that? Raheem?
I'm sorry, like what? Yes. What did you do? So 2.5. Yeah, but to solve it, I have a dr over dt. So your r is the one that you have on the right side of it, and then you'll put that over the square root of 2 point.
Yeah, so that's what I have here, because this is
Oh,
to the minus one
that's
half.
just for your dr. Yes, it
Right.
is. Yeah, that's
Yeah.
correct. Yeah.
So
I
so
got
now you
negative
spent.
half.
So now you, and also that 1/2, you can just take that out, right? Because that just divides out the 1/2, right?
You'll include it in your in when you're doing your final wait. Will you? Yeah, yeah, you'll put it your dr over dt will be 1/2 times what you're writing right now, and then over uh the square root of 2.5 minus what was it?
Yeah. 22.25 minus 497.31 t, and then plus 2786.58 t squared, and all of that equals 0.
Yeah.
Let me see, could you zoom into your board real quick? Oh, I don't know, I can't see the board real quick. I don't know, maybe somebody's talking.
I can't zoom in, but
Oh, no, there it goes. I can see now. So yeah, that looks fair. That's fair. Mhm. Let me see.
yeah. Okay. So everybody, we're all in agreement. This is the correct derivative and setting it equal to 0. Everybody in the class. Well, I'll just go with the people who are responding.
Yeah.
Kimberly?
Yeah,
Yeah.
looks good to me.
Hey, how you doing?
Raheem? Yeah, so
Yeah,
well
it
said.
look about right. That look about
All right. So to minimize this, it is that simple. I can just multiply through by the denominator, right? That's going to go out to 0. And then the 1/2 goes out as well. Like, so basically multiply everything through by 2. I can do that. And then multiply everything through by this denominator. And what that will end up leaving is 0 equals 5573.16 t minus 497.3. Then the next step is just solve for t. So basically t is equal to, minus sign, it goes out because it's bringing that over as plus, then t is equal to 497.3 over 5573.16. And that is consistent with what he got up at. That gives you a time of 0.089 hours
Okay.
for t.
And T is.
And then you have to take that t and you can put it back into this thing. And I'm assuming, let's just go ahead and do it since we just be complete.
Yeah,
We've
let's
done
just
all
check
this.
it
Might
out.
as well. Yeah, I might as well do it all.
Mhm.
Right.
Zero,
So,
8, 9.
Oh, and then I'll take a square root. Yeah. Yeah, so I got 0.24 and some change, but let's round off because I might have dropped some sig dig in there trying to do it fast. But yeah, so in the end, I got these answers: 0.25 kilometers and 0.089 hours. So you get when I put 0.89 hours into this, I end up getting a quarter of a kilometer, 0.25 kilometers.
Did anybody test it out? Or no, is anybody like logged into their school thing or they don't want to test it out? Or did somebody do this problem already?
Oh, I've done the problem already, but we all have different numbers. So I took your numbers and then I did it the way I solved it for my homework,
Uh-huh.
and that's how I did it.
Okay. Is it right? Did you test it out? Or
Well, my numbers are right, but my numbers are different. And so for my question 20, it's my numbers are different from yours. So mine is what is it, 20? But my angle is 39 degrees. So my answer is going to be a little bit different from
wait, what do you mean your
yours.
angle was 39 degrees? Is that what the
My,
question said?
yeah, my question is the angle, you know
Professor.
how yours is 37, mine's is 39. So
Oh,
the numbers are different for our question. The question
oh,
is
the
the same, but
software
the
is
numbers are different.
different for
Yeah,
different
all the
people. I didn't
questions
know
are
that.
different. Yeah.
Oh, okay. Thank you. I didn't know that. So they make it to where you can't cheat, basically. That's cool.
Yeah, yeah.
I didn't know that. That's what's up. Okay.
Professor.
Is it sound close though? I mean, mathematically, is it in the vicinity?
I mean, mine was correct. I did it this way, and my numbers were correct. But you can double check it for your peace of mind.
Yeah, but I'm just asking you, is it in the vicinity of what you put in your if you right there on the problem, if you're not looking at the problem, don't worry about it.
Yeah, my C was 0.0859
Uh-huh.
hours, and then my D was 0.208 for my homework.
Okay, yeah. So it's about the same vicinity. Okay. It
Yeah.
sounds
Professor.
correct. Okay. That's cool. Yeah. Well, evidently they give us different problems. I didn't even know that. I thought everybody was like on the same program. I didn't know. So, that's
The
cool.
problems are the same, but the numbers are different.
Yeah, no, that's cool. I was just saying like I didn't even know that because I never asked other people like about their homework or nothing. So I didn't know that.
There was someone else about to say, asking a question. I thought I heard someone else.
Yeah, it was me, Professor. I
Go
wanted
ahead.
to ask, where did you input the time?
You put it back into this equation for R of t that you have, the one that you took the derivative of. You have to put it back into that equation.
Oh, okay.
Because that's the equation that defines that line between the two. You know, I drew a line between the two. This is what, if you graph this equation, that's what it would look like. That's what pictorially, it's going to be the distance between the two boats at all times. You follow me?
Yeah.
Yeah. So if you put in a time that is supposed to be the minimum time, then it's going to give you the minimum distance. So that's the equation that you put the time back into. So I'm curious, Raheem, did you remember how to do this before we just started talking about it in class?
Yeah. When you were bringing up the question, I pulled up my homework and I was trying to remember how I solved it. So I remembered how I solved it, and I was trying to make adjustments because her numbers are different.
Yeah.
And yeah.
So that's cool. So you just remembered it. You like, what's your major?
computer science.
Cool. So you just remembered it from that process from calculus or something, or what?
Yeah, I'm taking calculus 2 right now too, and we're doing like integration and differentiation. So it's like it's stuff that we're doing now. So it's kind of on the top of my memory.
Right. Can you refresh me? Like from what I remember, I thought it was calculus 1, but is it calculus 2 where they do this? Do you remember?
They do it in both. They introduce integration and differentiation in Calc 1, and
Yeah.
in Calc 2 it's just it's still integration and differentiation, but then there's like substitutions and they're doing some different stuff now.
So they do get it. They do problems of minimization in calculus
Yeah,
2 like
yeah,
this. Yeah.
but all we're doing in the class like the whole time is like integration and differentiation. So
Yeah. Cool. So all right. Well, it's a good problem, Kimberly. I'm glad you asked it. You know, I wish I would have been able to do it faster for you, but whatever. It is what it is. That's how it came out today. But this is it. This is how you do these types of problems. It's a whole, like I said, back in the before Newton did his thing with the Newton's law, and we had that as a foundational principle of approaching the universe. This was one thing that people did. Like, you know, like there was no like fundamental theory that was like something that you could apply to everything. That's why Newton is considered like the king of physics, kind of, because before then we didn't have that. So what people did is they would just do whatever they could to a problem. And one of the things that people did all the time was minimizing a function. It was a big deal, like back in the 1600s, like around the time of the Renaissance. You know, it was like one of the first things that people do when they come up with a new function or something is minimize it, find some parameter within the minimizer. And usually it was time because, you know, that's usually like the independent variable relative to anything, time, temperature, something like that. So you minimize a function with respect to temperature, minimize it with respect to time. So even though, yeah, so it's one of those things that is a really nice tool to be able to solve problems. And it's purely from a mathematical principle. So it's something you want to be familiar with and know how to do. And so this is an example.
Professor?
Yeah.
Yeah, you remembered, you told me you will help me with the question. I told you I got all the answers wrong. You said at the end you will help me.
Yeah.
Yeah, I'm here. I'm waiting. It's time.
Okay. Well, yeah. Okay. So if there are no other questions, maybe you're going to have to put up your work for me to see it because I've done the problem here and this is what the problem is. So maybe you could share your screen with me and let me look at your work and I can go through and try to figure out what went wrong.
thank you,
Yes,
Professor. Enjoy the rest of your
Okay.
day.
Okay.
I can
Thank you.
go ahead and quickly just show it. It's just a board like this, and this theta is 36.
Mhm.
The dot is at 3.9 and 2.6. The velocity is 22. For that,
For A, okay.
for a velocity, v a equals 38.
Okay, so let's
V
replace these numbers up here then. So I think we have to go back and redo those. I left out some steps there. I want to keep this here so we can go back and just go from the beginning of your thing. So to set that up, yeah, keep that there. So 38, yeah. So what we would say, I'm going to start here. So we're going with that equation. R of t is equal to x squared plus, basically r squared is equal to x squared plus y squared. and this is x of t and y of t squared. Now your R for the initial conditions, I'm going to say that that's your thing. So that's 3 point. So the X is 2.6 kilometers squared plus 3.9 kilometers squared. I'm gonna put in the units. So kilometers have to equal kilometers. So over here, that was well, the y component of the velocity is just that 22. That was going straight down. So that's the y component of the overall velocity, the the velocity of the space or the line in between. So that's going to be 22, and that was kilometers per hour times hours times the time, and all of that squared. So that's the y. It only has one y. No, sorry, that's the x component. Not that. It's the x component that's like that. So sorry, it's the x component. So it's the it's the 38 times cosine of 36 times t. So it's that velocity times the time. So that's, in fact, let's go ahead and those answers up there. I'm going to erase this. I just want to keep that up there because I want to compare our final result to that to make sure we're formulaically we have it right. So I gotta do my link here. Okay, thank you for your patience with that. Yeah, so the x of t is going to be equal to v I guess this was for b, but it also is the x component of the space because the other one doesn't have an x component. So that was going to be vb times the cosine of, and your angle is 36, and your vb was 38. So 38 times the cosine of 36. Agreed? So your x component of your both v and for the overall line between them is 38 into 6 cosine. We'll store that. So store 0. So 30.74. So this guy is 30.74. That's kilometers per hour. So times the time is going to give you the length, at any time. So square. So 30.74. And x. And the velocity of the y component of the position of the space between the thing is going to be equal to the y component of a, I guess, when that's 22. So that's going to be 22, VA plus the y component of VB, which would be VB times the cosine times the sine of 36. So that's going to be 22 plus 38 times the sine of 36. And that component then is 38 enter 36 sine times 22 plus. So 44, 33. I'm going to store that in 1. So that becomes 44, 33. So this is in my register 1 and this is in my register 0. Okay, so then here, that becomes plus 44.33 times t quantity squared. Okay, so that's now your equation that you have to minimize. Did you get, when you set it up, do you have this anywhere in your notes? Like, did you do this?
Yes. I need to just quickly find it. Just a second. So for some reason I can't find it. The 2.6 squared plus 3.9.
Okay. Well, I'm gonna square this. I'm gonna get remind me, did we have to do that? Did we have to?
Oh, can I stop the screen share or the data will be needed?
I guess you can stop it. Yeah, I guess you can stop it. Yeah, so this became 945 t squared plus 196566 t squared. Store that in 4. All right. I've now forgotten what we did. So we had to, that's the function, and then we had to maximize by taking the derivative of that and setting it to 0. So I think I simplified it in a certain way to do that. And how did I do that?
We did, I think we square root, we got we were doing the square root of the part of 945 t squared.
That's just right here. So like that's going to be so that's just yeah. So we could write it like this: 4.6 times equals 30.74 t plus 1965. No, plus 44.3 t squared. No. Um, yeah. I was trying to get an equation for R of t, and oh, right. I remember now. It's not quite right. X of t is, I have to have the initial conditions up here. So, right. It's really using the equations of motion. What we want is the distance. So it's the x parameter, the x component of the line between the objects is, yeah, x of t is equal to x naught plus vx times t. That's what it is. So the x naught is the the 2.6. So 2.6 plus this component, 30.74 times t. That's the x of t. And the y of t is going to be equal to the 3.9, that's the initial value, plus the 44.33 times t. That's what it is. So then R of t is equal to, yeah, that's where this equation came from. Yeah. R of t, so basically, yeah, got it. R squared is equal to x squared plus y squared. So then R, and that's R of t. So R of t squared then is equal to the square root of x squared, which is 2.6 plus 30.74 t squared and I'm just thinking whether this is plus or minus. For the x direction is plus. For the y direction, it's plus, and the y is actually minus, right? Because I start up there at the top and I'm going down in the negative direction towards 0. Oh, this actually is minus 2 because that thing is decreasing. Yeah, as the bolts come together, so the x component is decreasing. So it's starting off at a maximum and decreasing. That's why there are minus signs in there. And so here, this is 3.9 minus 44.33 times time quantity squared, and this is not right. I'm gonna take that away. That's not what we want. And the square root of all of that. So that's actually what we need. So r squared is equal to that squared, but r is equal to the square root of that. Now that I'm confident about. So your initial value, you said the x value was basically both A is at 2.6 kilometers south and 3.9 kilometers north of boat B, right?
Mm-hmm.
Okay. And so the combined velocities are these things. And so then this is the rate at which the x component is decreasing. You're subtracting that from this initial position and subtracting the rate at the y from the initial y position. So that's how, so basically, so to get R of t, that's what R of t is. That's how we got it. So I can multiply all that stuff out, and that's going to give me, well, it gives me the square of R of t. So then I have to take the square root, and that's going to give me R of t. So that's how I get this comparable equation here. So let's just go ahead and do those. Let's do those out. So we're going to get so we square that and got to have the cross term. So it's going to be 2.6 squared, so 6.7. So this would be equals 6.75 minus the cross term is 2 times each one of these, and it's minus. So 2 times I should not round off. So that's going to be, so that's going to be one, 159.8 times t. And then the last term, let's store this in
Professor.
Yeah.
But isn't 2.6 times 2.6 equal 6.76?
Two 2.6 times 2.6 is equal to what?
Isn't it equal to 6.76? Not 75. I got 76.
Yeah, you're right. Sorry, I misread. Thank you.
Mhm.
Now the other guy.
Okay, I saw already one error in my solution. I was just checking my solution, how I did and how we're doing it right now. I multiplied, I wrote 3 points, I wrote 4 on place of 3.9 when we were squaring it. So I got 16, not 15.21.
It is 3.9, right?
Yeah, it is.
Okay. That could make some difference, I think, because it's going to affect all these terms here. And well, the two
But
terms.
before this one, the answers to questions A and B, they are like symmetrical, exactly what you got. It just they're wrong. And it shows where when I submitted.
What are the answers that what are their answers?
They didn't show. I didn't submit it 3 times to get the answers. I can share the screen. It's gonna show like what I see. So here it is. It says here is the information. Here are the questions. Here are the answers.
Yeah, well, it may be one of those issues where, maybe it wants maybe it wants, who knows what it wants. Maybe it wants 44.3 4 or something. I don't know. It could be that situation. So you just have to submit it, and if it's wrong, then you let me know, and I'll correct it. But other than that, if you're getting this, then that's good, and I can go ahead and do the other two. But do you think like I'm if you knew what to do, maybe you didn't make a mistake. Maybe it's just that it's harshly grading it unfairly. Like that might be what's going on. You understand?
Yeah, I thought maybe like I understood it wrongly. That's why I got all wrong. That's why I just came up to ask if we could solve this one together. But we can just continue quickly, finish the last two questions and go ahead.
Yeah. And when you like, it'll give you the correct answer before you turn the homework in, right? Like, does it immediately gives you the correct answer once you submit that particular problem? Is that right?
It gives the correct answer when I'm out of tries.
When you're
Or
out of what?
if I got the answer correct, it just doesn't give the correct answer. It's like it says like I submitted it correctly, so doesn't give like correct answer on its own.
So, Hayek, my question to you is, when you submit your final solution, does it give you the correct answer immediately, or does it wait till you turn in the whole?
It gives immediately.
Yeah, that's what I thought. So what we could do is we could, go through and do this, and my guess is that we might actually get the answers you got. It looks like you know what you're doing, and then you can submit, and then then we can see. But my guess is, because I don't believe that those first two answers are wrong, and they marked it wrong, so that suggests that it's just one of those glitches where it's marking you harshly for, and I actually think these are the correct significant digits, which is what you wrote. So I don't know what they wrote. Anyway, we can see. We can go for it. So yeah. So this is what I have for RFT.
Mm-hmm.
Actually, well, that's RT squared. So to take the square root of that, then I have to now take the square root of that. So this equation is the equivalent one that we had for Kimberly up here. So now this is the function that we have to maximize. Okay.
Mm-hmm.
So, or I guess minimize.
Oh, Professor.
Yeah.
The 159.8 T. It was a negative. I think it was negative.
Yeah.
It's a 185. The negative 159 and
Oh,
negative 345.
oh, my bad. Okay. You're right. Thank you for catching that.
Mhm.
That's correct now. 505.68. Agree?
Mhm. Yeah.
Yeah. Okay. So now we have to take the derivative of this thing and set it equal to 0. So zero equals dr dt, and that's going to be equal to well, actually, I know that's going to go out, isn't it? So I'm just going to put that in the brackets so that's going to be, yeah. So taking out the 1/2, I have 1/2 of that, and then all of this to the negative 1/2, and then the derivative of the inside, and that's going to be, or times, and that's going to be 0 for the first term, minus 505.68 t for the second term, and then plus 2910.77 t squared for the third term, and all of that equals 0. So now I solve for t, and what we showed before is that I can just factor through these two terms. So, right, this is in the denominator. Let me just clean it up. I'll clean it up one more step. So 0 equals 1/2 of this stuff minus 505.68 t plus 2910.77 t squared over all of this stuff, all the stuff in the brackets, which is this right here. So solving that for t, I can just factor through by t and, by 2 and this thing. So then that just reduces to 0 equals just this denominator, minus 505.68 t Oh, did I?
Yes, sir.
Sorry. Yeah, this should have been 1 here. It's not a t. Because I
Yeah,
took the
I was
derivative.
thinking,
Yeah.
weren't we supposed to take out the t's and
Oh,
the
take
b
the.
squared become 2 t1?
That's right. They do. I didn't take the derivative, did I? I just wrote it
Yeah,
down again. So that's 1. And so this is 2 times t to the 1. You're right. So my bad. Sorry, I'm just tired and hungry. 2 times t to the first power, taking the derivative of it. Thank you. The same thing here. 2 times t, the thing, and then this is just the 1. Yeah. So 1, and then plus. So let's go ahead and square that then. So I had saved that in register 2. So we call 2, and then square it 2 times. That becomes 5,821.55, and that's t. And so that's stored 3. So register 3. And this one is still in register 8. And so then that says that t then is equal to, the minus sign will cancel, and I've got 505.68 divided by 5,821.55. So recall 8 and recall 3. And divided. Yeah. And so what I get is this time t is equal to 0.08669, or 0.08686 is what I get.
I'm on the way to it. Just a second.
Okay.
Oh, okay. Yeah, that looks good.
So you got that? Okay. So now we take that number and we put it back into equation 7, and that'll give us what distance it should be.
Mm-hmm.
By the way, was this the answer that you had put in your, because I can't remember, in part C?
I've put it 0.088, I think. Let me just quickly check. Yeah, 0.088.
I mean, that's not worth 0.8 of a point, but I think this is more correct because I didn't truncate anything here. But still, they shouldn't have taken. I mean, that you basically, it shouldn't have taken off. I think you got it right. It shouldn't have taken off 9/10 of a point by any stretch of the imagination.
Mhm.
So yeah, let's put this in and see what we get then. So recall 8. This is in register 4. Times recall 8. 8.
Oh, did we input the time before before taking the derivative or after taking the derivative? Before, right?
I'm not following what you mean. Can you say that again?
No, I said it out loud and understood that I was asking a stupid question. It's okay.
I'm sorry. What's going on?
No, it was just stupid question. After I said it, I understood, so no need to help with it.
Well, don't say it's a stupid question. No questions. Don't beat yourself up like that. But yeah, so now, actually, I got a pretty small. Well, actually, it's kilometers, but still, it's pretty small. I got like 0.00734 kilometers.
I was having a similar issue. I thought it's like a too small value. Then I calculated it again. I got too big of a value. Then I just calculated a few times until I got something close to your number and put it for something, but it was also too big.
I mean, 0.007 kilometers is still 7 meters. So that's pretty. I mean, that's pretty close call, but it's not unreasonable. It's not like 0.007 meters. You know what I mean? This is actually pretty reasonable. It's probably the answer. But I'm just going to do it again. Do it again just to make sure I didn't make an error. So, I mean, it would make a lot of sense for this type of problem. If that's a pretty close call. I mean, if you're on a cruise liner or two cruise liners, you definitely don't want to come 7 meters within hitting the thing. Another one, right? That's like Titanic type stuff. So I could see it's an interesting problem. But let's see here.
Mm-hmm. HT plus.
Yeah, I got the same thing. I think that's right compared with the numbers we got here. So I'm gonna go ahead and bake that in. So I get that my R value is so this is our min basically is equal to 0.00734 kilometers. So that's basically 7.34 meters. It's not an unreasonable number So that's and what did you get? What's the answer that you put in? You probably got something like that before.
I'm calculating it right now. It's just it took me a little time to write it down.
Okay.
Times. Then I add. Oh, also then we do a square root of it.
Oh wow, that's it. That's what it is. I forgot to do this for my bad. That's what it is. Yeah, so 0.085. Yeah, okay, thank you. That's what it is. That changes it by a factor of 10. So it's like 80 point.
I
85
still got an error again. Somehow I'm calculating this. Maybe it's the last step. I'm taking 21.96 minus 505.68 times the t is the 0.896.
I'm
But
not following what you're saying there. When you say an error, did you get this number for R min?
I'm gonna count it one more time, then I will say for 100%.
Just please tell me what you got already. What did you get for R min?
I got negative 43. I can't do square root of negative.
Okay, so yeah, so again, that's what I was talking about earlier. Part of this is just procedurally, like you don't have your system down, about how you use your calculator and solve it, storing numbers and things like that. It's a process. You got to learn just what you like to do best so that you can efficiently go through. And it just takes time. I did the same thing, you know, until I figured out what I had to do to make sure I was as efficient as I could be. You know, punching numbers still isn't my strong suit. You know, in working with numbers, I more would rather work with symbols. But in the end, sometimes you just have to do it, and so you have to try to make it as efficient a process as possible for yourself. You know, some people can whip through this stuff, you know, in no time. I can't because I'll never get the right answer. So I have to be very systematic about how I do it, but you know.
Yeah. I've solved one of my issues, but I still got like 6.627,417,
For what?
something like the R mean.
So did you get this answer here for time?
Yeah.
So there's no way you can get another answer other than this if you're using that for time in this equation. So you're doing something algebraically wrong. Unless I made a mistake, but I don't think I did. I did it a couple of times. I'll do it again. And we were in agreement up to this point. So I think we're pretty sure that this is the correct answer for this, right? That's what you got. So there's no way that you can put this into this thing and not get that answer.
I know I'm doing magic, so okay. I'm gonna try to get it a few more times until I get the correct answer. But now I will need to leave because I have a class soon.
Okay, so before you do that, we don't need to, you can work on the algebra on your own, but let's go back now and go ahead and submit that, you know, with these answers here, submit the solution on the homework and let's see what they say for the,
Okay, I'm gonna do it right now. Okay.
show me as well. I want to see.
Okay.
Share the screen.
Share the screen.
Oh, Armin, I didn't know someone was still there.
Yeah. Okay, yeah, here is the screen. The values for these, I think we got the same.
Yeah.
The number is this thing. The time is that.
Oh, so you got C right, it looks like. Oh no, you just putting
No,
that in. I
I've
see.
just corrected it.
Okay, go ahead. Go ahead and put it in.
And this one is 0.0.
I mean, if they got those first, I think all of them are going to be wrong, but I think it's just going to be off by like a tenth of a point or something like that. So go ahead and let's see.
Oh, this one I inputted the time incorrect. I've put it I was supposed to put 7.
0.08. Yeah.
Okay.
Okay. So let's look at the solution. So it's marking them wrong. Okay. Look at the solution.
Okay. I'm gonna stop the screen share. Should I try to find another way of solving? Maybe Google it or search something similar to it, or?
I'm asking you to. Did you hear what I said? I thought you were like, let's look at their solution. Like, pull it up.
It was my second attempt. I have one more attempt, so it doesn't show the solution yet.
Oh, well, that's what I was asking you. Submit it. So like, because this is the way to do it. Like, I think they're wrong. Like, there's nothing else to do. This is the right solution. So if they're marking it wrong, like we can go ahead and verify that. Like, I don't think I'm doing anything wrong, right?
Okay, then I'm gonna submit it one more time.
Yeah.
Oh,
So now let's look at the solution. Yeah.
There is the solution.
Yeah, they got the same answers. That like this is what it is. It's just one of those stupid, you know. See, they got it right there. Minus 30.7 and minus 44.3. Now go on down and get the time and the distance. So they're doing the same thing. So that's what we did. We maximize the function. Keep going, find the final thing. Yeah, it's the same answers. R is equal to 0.0857. I don't know why they got 57 because I'm pretty sure. Oh yeah, 0.0857 is RM. And then where's the time? 0.0869. Yeah, I don't know what to tell you, man. I think it's a coding error. I think it's a coding error. You know,
Okay.
and so you just have to get used to that. And you know, whenever there's an issue with this, go ahead and finish it and write me an email, and I'll go back through and just put the number so I don't have to, because it's just too much for me to. It's impossible for me to find it for you. You just have to tell me which ones to look at. I'll look at it. I'll check it quickly, and then I'll give you the credit. You know that in this case, I would have given you back full credit. Okay.
Okay. Thank you, Professor.
Okay. All right. All right. Thank
Thank
you.
you, Professor.
Thank-
Have a good.
Yeah. All right. Armand, were you just following along, or did you have something else, Armand?
No, I was just following along.
Okay. All right. Cool. All right. Have a
Thank you.
have a good evening. I'll see you on Wednesday.
All right.
See you on Wednesday. Thank you, Professor. You too.
Okay. All right. Bye bye. Good. I would. I really would. I can't. The only thing that I can do is give you the tools that at some point you will be confident where, and you just have to trust me. It will happen. Slowly, but surely it will happen. You just have to keep doing this every time.